Okay. Hi, everyone. I'm Gianluca. Glad to meet you all here in the Droidcon London this year. Sadly, not in person yet, hopefully next year. And I'm one of the Android developers in Compare the Market, a company that was launched in 2006 on a mission to make great financial decision-making easy for everyone. Also very famous in United Kingdom, but also abroad for our meerkats. And I'm very passionate about open source, where I'm one of the core maintainer of Dangerjs Kotlin. And yeah, so I hope today we can show you something new. Here you can find my contacts, GitHub, and Twitter, but you can also find me on the Kotlin Slacks and Android Studio Group Slacks.
Hi everyone, I'm Franco Meloni, Senior iOS Developer at American Express. I'm also really passionate about open source, where I maintain Dangerjs Swift and Dangerjs Kotlin. Today, standards are everywhere. One of the biggest issues for team is to keep consistency across the team. And bigger is your code base, more you would like to have standards and checks which everyone follows in order to keep your code base clean and easy to maintain. However, bigger is your team, harder is to actually have shared standards. They usually are defined in different places. Sometimes you define them in GitHub issues, documentation, GitHub discussion, but also on Slack threads, or sometimes are just verbal agreement you have during meetings. And so the best place to enforce those places is actually in pull request, and usually they have to be catched by a human pull request review. So this requires a lot of time for the reviewer to actually find all the issues in the PR, but also sometimes they can miss one, and so something against your rule can actually be merged into your main branch. To make a simple example, let's say that the designers showed us a new error view, and this error view, differently to the old one we had before, has the retry button. So we need to define on a case-by-case basis what happens when you press the retry button, and that cannot be automatically migrated from the old one to the new one. So our approach to the migration will be to rename the old error view to legacy error view, and create a new error view and do gradually the migration. However, during the migration, we would like no one to actually use the old legacy error view. And possibly, we would like to have something automated. We check that the legacy error view is not used, so that we don't have to manually check on every PR if the author uses the legacy error view. A possible solution to the problem is Dangerjs. First of all, what is this Dangerjs tool? Dangerjs is a customizable tool which runs during your CI. It has a new logical step on your CI where you can automate all the common things that your team usually check during pull request. So it gives more focus to the reviewer to the actual PR changes instead of to actually enforce the standards. Dangerjs is uses in a lot of famous open source projects, but is also available in different languages. It's available in JavaScript, Swift, Python, Rust, Ruby, and of course, Kotlin. One of the main goals of Dangerjs is to keep the feedback loop really short, so that when you open a PR, you immediately know if something is wrong and you can immediately address it, even before the first reviewer arrives. In order to do that, you need to run Dangerjs as soon as there is something that can go wrong. So this means that you don't necessarily need to run it only once, but for example, you can run it when you push the code to verify something that something is wrong in your added or modified file, your branch name, your PR size, etc. But then you can run it also after the build to, for example, verify that the linting process was okay, check if there were build failures or test failures.
And I like to call Dangerjs Kotlin a Kotlin sandwich. And this is because all the communication between Dangerjs Kotlin and your GitHub, GitLab, or Bitbucket is basically handled by Dangerjs JavaScript, Dangerjs. So as you can see here, the data flows from your GitHub, GitLab, or Bitbucket go through Dangerjs, that is the bread, and then we process all this data in Danger Kotlin, and then the data is go back to Dangerjs and back to your pull request. All the new generation Dangerjs in other languages as well, like Swift, Python, or Rust, are using this modern architecture. And we can have a look a bit in details, like when we were a kid and we love to open the sandwich and get only the cheese or the ham from inside. So let's see how Danger works. We have a Danger Kotlin binary that is the one that is invoked on your CI. And this Danger Kotlin binary basically is going to get the data from Dangerjs that pulls pull request JSON from GitHub, GitLab, or Bitbucket. So there is all the data about our pull request is coming back to Dangerjs and back to our binary. And after that, our fantastic Danger Kotlin binary have a Danger file there that compiles. And we are basically converting all the pull request data into Kotlin objects that we can process inside in our Danger file. So you will see we can have information like a target branch, deleted files, branch name, modified files, author, and so on. So after we processing our Danger file, with the help of the plugins that we will be covering a little bit more in detail later, we produce an output that is 4 arrays, basically. One array for the messages, warnings, failures, or suggestions that your team has defined. And all those messages, warning, failures are published back to your pull request after. So yes, one thing that I would like to mention at this point is that Danger Kotlin is using two of the latest technologies provided by JetBrains. One is the Kotlin scripting because the Danger file itself is a specific Kotlin script specifically designed for Danger. And then the Danger Kotlin binary that is developed completely in Kotlin, 100% Kotlin, using Kotlin native. So as you can think, we have two binaries at the moment. We have a binary for Mac CIs. We have a binary for Linux CIs. At the moment, still, we are not supporting Windows, unfortunately, but probably we will support that soon later. And to enforce what I said before, here is where the data come back and finally is published back to your pull request. So Dangerjs can update the pull request and the PR status, make it fail or make it succeed. So all green, all red, all warnings. And this one is a Danger file where basically the magic happens. Danger files are the places where you can write your own rules, and is the file, as I explained already before, is compiled by Danger. And yeah, you can see in the top we have two keys annotation, the repository and the depends on, that will allow you to import anything from Maven Central or external Maven dependencies if you want to declare one. Import section, and then you can register the plugins if you are using some. And finally, we have our Dangerjs block that is the place where you can write your own checks.
Danger is a tool which is built to adapt to the team that uses it. It works for a small open source project as well as big enterprise companies. This is because it doesn't come with a predefined set of rules, but instead it gives you a framework which make easy to write your own checks. During the next slides, we will go to a few examples that shows what you can do with this tool. First of all, going back to our error view example before, we built two different approaches, one that is soft and one that is harder. So this one tries to understand every time a new instance of the legacy error view is added. And so it uses gitdiff to count the times where a line with legacy error view is added and the times where that line is removed. So if the other lines are more than the removed line, it fails, suggesting to migrate from the legacy error view to the new error view, but it tries to understand, for example, if you were just reindenting the code or just moving the legacy error view around, or if you were actually adding a new instance of it. But we also have another approach, which is a little bit more restrictive. So this one tries to understand if you touch the file that contains the legacy error view. So it requires everyone that creates or modifies a Kotlin or XML file which was using the legacy error view to migrate that. So it gives everyone a little bit of tech to do. And in case the file contains the legacy error view, Danger adds a comment in the line that it's using the legacy error view and forces you to convert it to the new error view. According to the best PR pull request practices, the size of the PR should be small enough to allow a simple review. And so we try to estimate what a small PR is, and we said that a small PR is everything where the difference between addition and deletion is less than 300 lines. So if a PR contains more than 300 lines, then we add a warning, and we say that it's a big PR, and so we suggest to split it. Another good check while we're migrating from Java to Kotlin is a check that forbids from the author from creating a new Java file. So it goes through all the created files, checks all the files that have extension Java, and if there is any, he adds a failure on the first line of that file, asking to create it in Kotlin instead. Finally, let's assume that we have a release branch, and all the PRs to the release branch needs an additional review, for example, from one of our tech leads. And so we can add a check on Danger, which checks if the branch we are merging to starts with release, and in that case adds a warning which tags the people that should actually review it, so that they receive an email. But also, if we have available something with a webhook every time a review is submitted, for example, we're using GitHub Actions, we can do this check a little bit more restrictive. So we can actually check if the reviewer approved the PR and fail otherwise, so that the PR is mergeable only when it receives the required approvals. There are a lot of other checks we can do with Dangerjs, but the important thing to mention is that automation brings more automation. So even if you start with really simple checks, with the time, the team itself will identify cases and checks that can be automated by Dangerjs, because they are doing it in every PR. And so at the end, using Dangerjs will save a lot of review time and will improve the overall code quality. All right, so now we will go through how we can set up and install Dangerjs in our CI and our machines. First of all, the easiest way is probably use GitHub Actions. And so you can use a YAML like the one in the slide, which automatically pulls the pre-built Docker image that contains Dangerjs Kotlin and runs it in your PR. But if GitHub Action doesn't fit you, or you want to install it locally, you can use Brew if you're using a Mac machine, or you can use the script available in the GitHub repo if you're not using a Mac or you don't want to use Brew. Once Dangerjs is installed, invoke it is really simple. You can use a Dangerjs Kotlin CI if you're on CI, and optionally pass the Dangerjs file, for example, in the case you have more than one Dangerjs file. But you can also use Dangerjs Kotlin local to run Dangerjs Kotlin locally with the difference between your branch and your main branch. Or if you want to run Dangerjs Kotlin against a real PR, but locally, you can use Dangerjs Kotlin PR and the PR link.
And the other version of Dangerjs, like for example, Dangerjs Swift, require an additional command to edit your Dangerjs file. This is because we need to create an environment where we can import the Dangerjs library, so to be able to autocomplete and to use the danger file, edit the danger file easily, and not like just a plain text file. So what we do with Danger Kotlin, rather than create a satellite project that we need to open with IntelliJ and then edit the Danger file there, we can do that just importing our Danger Kotlin jar. So you need basically to install Danger Kotlin in your machine. And then after importing the Danger Kotlin jar in the Kotlin script section in the Kotlin compiler in your IDE, that can be either IntelliJ or Android Studio. So this gives you an additional benefit that is you will need, you can stay in your IDE and not switching projects when you have to edit the danger file. So you can keep an eye on everything on the same project. And as I mentioned before, another cool things are the plugins. We can extend Danger with a lot of plugins, and at the moment we don't have a lot of plugins available for Danger Kotlin because it's still young. But the important thing is that if you we have some of the plugins, like for example, we have a plugin for Detect, we have a plugin for Jira, we have a plugin that I've personally made for publish on pull request your Android links checks. I think if you want to contribute to Danger Kotlin, probably creating a new plugin is a very, very good start. And create a plugin is quite straightforward. You can check out an existing plugin from GitHub if you want, or you can just create a new Kotlin library project and use as a dependency our Danger SDK. So after that, you can just create your plugin class or classes where you just need to extend Danger plugin and create your methods where you can communicate with Danger through the API. So you can see here we have a context message. So that means you are going to publish on your pull request a message directly from your plugin. And then next steps are, of course, testing, because we don't want to publish a plugin that is not working properly. So we need to test that on our CI first. So you're using Danger in your Danger plugin CI. So it's a bit recursive, but it works quite well. You will have, once installed Danger Kotlin in your machine, you will have a plugin for Gradle called Danger Plugin Installer. So you just need to add to your Gradle file and then apply the plugin. And after that, you can basically upload the jar of your plugin directly inside your local copy of Danger or your CI copy of Danger. So then after that, when you tell to Danger where the output jar is, you can just import that in your Danger file on your CI. So by importing the plugin, then you can register that and then use it. So you can test on your own CI if your plugin is working properly. And next step after that, it will be define your rules, your Gradle task for the Maven Central or other Maven repository publication. And yeah, so this is a personal list of plugins that I would like to have, just to give you some ideas in what you can implement if you wish. And I would like to have more wide GitHub APIs plugins where you can read the labels, so check which one is the label on your pull request, or put the label automatically if you want on your pull request. Integration with Firebase Test Lab, that is a thing that could be very useful. Or if you don't like to have a mess Git log, Git history, you can adopt the Angular commit format check that will basically force the developer to format the commits properly so your Git history is not mess. You can implement plugins for test coverage if you want, or a thing that I particularly like is if you are using screenshot tests. So basically by running the screenshot test, you will you will take a screenshot of your app before and take a screenshot of your app after a change. So you can see if the screenshot is the same, then everything is good. If the screenshot is not the same, then the test is a failing. So imagine the benefit if you can publish that directly on your pull request, so you don't have to digging in the logs and see which one is the screenshot failing and try to find the image and open a diff and check where exactly is failing. So you are saving a lot of time with that, and it's absolutely beneficial. And another thing to mention is the Danger Kotlin also supports coroutine. Here you can see a suspend fun where we have an expensive check. For this example, quite easily, we just delay for some milliseconds. But imagine that you can also do a network call or perform a high computation task here, or like, for example, the example Franco told us about before for the git diff to check. Here is because the git diff is a bash command, so you can run that asynchronously if you want. You can run all of those kind of tasks inside in a coroutine, and then as you can see here from your danger args block, you can run all the coroutines inside in your run blocking and in async. So we are keeping the feedback loop very short. If we have tasks that takes time to run, you can run them inside in a coroutine, and then the danger file will execute much quicker, and it will come back to you with feedback as soon as possible. So then the developer will see the comments on the pull request early. However, using coroutine is recommended only for really time-consuming tasks, like as I said before, a network, high computation, bash commands like git lfs or GitHub APIs. I wouldn't recommend using coroutines for simple checks, because keep in mind we have our list of modified, deleted files, so looping in a list of 10 modified files and check them one by one is still a for loop of 10 modified files, so it's quite quick, and it doesn't give you any benefit to put that inside a coroutine. So it's better you execute that directly inside your Dangerjs block and keep coroutines just for heavy stuff.
Before going to the final slide, we wanted to leave you with some advices we've learned during our experience with Danger. First of all, in some cases, a warning is legitimate, but in general, you would like to write your checks as precise as possible so that they can fail when the conditions are not met. So that is a simple yes or no, because having a warning requires the author or the reviewer to do an additional step to decide if they actually need or not to fix the warning. And this additional check makes the danger check less valuable, because requires a human intervention and also makes the feedback loop longer. And again, to keep the feedback loop short, we want to run Danger only on what is changed. And as said, Danger offers an array of added, modified, and deleted files. So you can use that to refine your check and speed it up, so that is as quick as possible. I think the third one is kind of self-explicative. Like seeing a failing test not only proves you that the actually check works, but it also shows you that is exactly it generates the comment you want. So it has the right markdown, and in case of an inline comment, is also posted on the right line. Finally, getting a failure on CI might be frustrating. So it's always better to add a message on how to fix the issue, other than just fix the issue, because you cannot really argue with the tool that is telling you that you need to fix something. So we need to make the experience as straightforward as possible. And so instead of, for example, just telling you need to format your code, you can also add the command to format the code, so that the author can immediately run the command, have danger passing, and have a green build.
And finally, here is like a list of what we do with Danger Compare the Market. At Compare the Market, we use Danger for both Android and iOS teams. And of course, the iOS team will use Danger Swift. But briefly, what we do is checks about a branch naming strategy. We have our own branch naming strategy that everyone needs to respect. We do generic PR sanity checks, linting, request reviews from people on working on your same feature, for example. We do not allow Java files, and same way like the example before, migrating the error view from the legacy one to the error view. We are migrating from JUnit 4 to JUnit 5 at the moment. So we're going to detect in the changes in the pull request if someone is trying to use JUnit 4 and make the PR failing, suggesting using JUnit 5 if not. We also do some check for Android context misusage. Like, for example, you're using the Android context in the wrong place. We allow the context to be used only in activity, fragment, custom views, but is not allowed to use the context in view models, presenters, and so on.
On American Express, we use Danger as well, both Danger Swift and Danger Kotlin. And we have a lot of checks, but the most interesting one are we have our own semantic correls, so we check if you're using those instead of the system ones. Every time an add suppress is added, we require a comment adding an explanation of why that add suppress is added. For now, auto-generated PRs, where applicable, we request a Jira ticket. And finally, we suggest to use our custom version with the bounds of the on-click listener instead of the system one. We just released Danger Kotlin 1.00, which offer a better plugin SDK and also has integration with Kotlin X serialization and Kotlin X datetime. And for more information, you can come on the website. Before finishing the talk, we wanted to thank all the contributors which helped us to make Danger Kotlin what is today. And if you wish to contribute, you can check out our Danger Kotlin GitHub repo.
And that's all. So yeah, I hope you had a great time, learned something new. I would like to thank you, everyone. And here you can find the links if you are interested to follow Compare the Market social and blog pages. If you want to know more about current and future opportunities, have a look.